Hey everybody, another constant support video. This one's on finding the constant proportionality from tables. So it says which table has a constant proportionality between y and x of 10. And so basically all it's going to be is the ratio of y over x. If it's a proportional relationship, the ratio of y over x is always the same, and it is in fact your constant of proportionality. It's what you multiply the input by to get the output. So in this table here, you're just looking at 20 over 2, which is what? 10. So that looks like it's pretty good. If it's consistent. Is it consistent? Well, what's 132 over 12? Is that also 10? No. See, 2 times 10 is 20, and 20 divided by 2 is 10, right? But 12 times 10 is not 132, so this is eliminated. This one is another candidate if it was a ratio of 10 between x and y. So y divided by x, ratio of y over x needs to be 10. Is 20 divided by 5 10? No. So that's eliminated. This one's 90 over 9. So 90 divided by 9, is that 10? Yes. Is 140 over 14 10? Yes. Is 240 over 24 10? Yes. Boom. That's the right answer. It has to be the same, right, throughout the entire table. So the ratio of y over x must be constant, right? That makes a proportional relationship. And then in this case, they wanted that ratio to be equal to 10. In other words, input times 10 equals output. Is the input times 10 equal to the output? Yes, it is for C. Let's do the next one. Which table has a constant proportionality between y and x of 1/6? Okay, so this time you're looking for a ratio of 1/6. So you're looking at output of 1 and input of 6. So a y value of 1 and x value of 6. All right, so let's first take a look. This one's an obvious one that we can start with 12 and 2. Does that make sense? Well, when the ratio of 12 over 2, 2 over 12, simplify would be 1/6, so that looks pretty good. What about 14 over 24? If you simplify that, you're going to get divide top and bottom by 2. You get basically 7 over 12. Well, 7 over 12 is not the same as 2 over 12. So this is not going to work. This is that's not even a proportional relationship. This one here is 1/3. That's not going to work because 5 over 15 is 1/3, so that's eliminated. Or maybe it's this one down here. 3 over 18 is 1/6. That's true. 4.5 over 27. That's the same as 9 over 54. Is 9 over 54 the same as 1 over 6? Yes. This is the same as 11 over 66. Is 11 over 66 1/6? Yes. So C is the one that works. Okay. Which table has a constant proportionality between y and x of 1.5? So basically, x times 1.5 equals y, which means that the ratio of y over x is 1.5. So is 5 times 1.5 7.5? Yes. Is 13 times 1.5 19.5? Well, 13 times 1 is 13, and half of 13 is 6.5, and 13 plus 6.5 is 19.5. So yes. Is 23 times 1.5 33? Well, 23 times 1 is 23, and then half of 23 would be 10 plus 1.5, so that doesn't seem to work. So this isn't going to work, so that's a no. So the first two are promising, but the third one doesn't seem to work the same way, so I think this is a no. 8 and 9.5 definitely is a no, because 8 times 1.5 is not 9.5, so that's eliminated. 8 and 12. 8 times 1.5 is that 12? Yes. 8 times 1 is 8. Half of 8 is 4. 8 plus 4 is 12. 9 times 1.5 is that 13.5? Well, 9 times 1 is 9. Half of 9 is 4.5. 9 plus 4.5 is 13.5. That's good so far. And 18 times 1.5 is that 27? Well, 18 times 1 is 18 plus half of 18, which is 9. 18 plus 9 is that 27? Yes. So C looks like it's the best answer because the ratio of y over x is always 1.5. 12 over 8 is 1.5. 13.5 over 9 is 1.5. And 27 over 18 is also 1.5. So your ratio of y over x stayed constant and is the right value. Let's look at the next one. Which table has a constant proportionality between y and x of 8/5? So y being 8 and x being 5. Change y, change y. Just the ratio of y over x. So looking at the situation here, there's some funky fractions and stuff. Let's just start with whatever is easiest to look at. All right, let's do this. This one's 10 and 16, right? So let's see if that matches 8 over 5. So that means that when y is 8, x is 5. So when y is 16, x would be double 5, right? Because 16 is double 8. So y would be 10. This looks pretty good. 16 over 10 is the same as 8 over 5. Here you've got 88 fifths over 11. So what happens there? 88 fifths over 11, is that the same as 8 over 5? Well, 88 fifths over 11 is the same as 88 fifths divided by 11, which is the same as 88 fifths times 1/11th. The 8 and the 11 cancel out to be 8 and 1. So yeah, this is the same. So this is promising. Let's see if it works for this one up here. So we've got 8 fifths is the ratio we want. So we ask ourselves, all right, we got 32 fifths, and we're going to divide it by 4. Let's just do a little bit of math here so you guys can see the process. There we go. Let me clear this out. Yes, a new blank whiteboard. Okay, cool. So if I was just testing A out, I know the other two work, right? So let's try the top one here. So 32 over 5 divided by 4, is that the same as 8 over 5? Are these equivalent? And there's lots of ways to do this. I think the easiest way to check it is to do the cross product and see if that is the same. So you just go, all right, 32 fifths times 5, is that the same as 8 times 4? Well, 32 fifths times 5, those cancel out. You get what? 32. And 8 times 4 is also 32. So yes, they are the same. So it looks to me like A is the right answer because it works for all three. That's how you do it.